So let's look at this particular problem. If tan theta equals t, show that sin 2 theta equals 2t out of 1 plus t squared. Now, over here, we have tan theta equals t. But we know that any number can be divided by 1. So with this theta, you can assume that theta is divided by what? 1. Okay? When questions of this nature, whenever you get questions of this nature, and there's no denominator given, try to give it a denominator which is 1. Okay? Then after that, the next thing for me to do is to draw our right angle or triangle. Our right angle triangle. For things to be easier for us. Okay. We know that the side which is opposite to our right angle is known as what? The side which is opposite to the right angle, the hypotenuse. Yeah. Hypotenuse. Okay, good. Now, we know that it's hypotenuse because for hypotenuse, there's no controversies about it because it is always opposite to the right angle. But as for the opposite and the adjacent, depends on where theta will be. So if I have my theta over here, if I put my theta here, then we ask ourselves what is the opposite side of theta? Okay, so this side becomes what? The opposite side. Then where has theta laid itself? Which is the adjacent, right? So this side becomes adjacent. So if theta is over here, opposite comes here, adjacent comes here. As for the hypotenuse, no complaint. Okay, good. So over here, we know that tan theta equals 2 out of 1. And tan, when tan takes angle theta, what ratio does it produce? Tan theta is equal to what?
12.
Tan theta equals opposite over adjacent, which is 12, right? Opposite over adjacent. So in this case, our opposite is what? T. Adjacent is what? 1. Can you see that? So we put our opposite to be t, adjacent to be 1. It means our hypotenuse is missing. And we have to find our hypotenuse. And what theorem can we use? Pythagoras. So with the Pythagoras theorem, we said hypotenuse what? Equals opposite squared plus adjacent squared. So here hypotenuse we don't know, right? Then we have opposite is what? T. So we have t squared, adjacent 1. Okay. So here we are looking for h. So what do we do? We take square root of both sides, right? We are going to have square root of okay, so this square root will cancel this square off. Our hypotenuse equals square root of t squared plus 1. Okay. Remember that we can cancel this one. Yeah, by no means. They move together. So that's what we have. So our hypotenuse is t squared plus 1. So with this idea, we can find the other ratios, right? You can find sine and also find cos. So let's find our sine. Okay, let's have our sine there. So what will be our sine theta? From this diagram, sine theta. Opposite over hypotenuse. So sine theta equals opposite. Our opposite is t, right? Out of square root of t squared plus 1. So this becomes our sine theta. Opposite over hypotenuse. What about cos theta? So here, what is our adjacent over here? We have 1. Adjacent is 1, right? Over hypotenuse. So 1 out of. Okay. So now we have our sine theta to be t out of square root of t squared plus 1, which is opposite over hypotenuse from this diagram. Then there's cos theta equals 1 out of square root of t squared plus 1, which is adjacent over hypotenuse from this diagram. Now, we said we should find sine 2 theta. Sine 2 theta. And with our double angles, we know that sine 2 theta equals what? From double angles, sine 2 theta equals
sine square.
Are you sure? 2
cos square.
2 cos theta sine what? Theta. Double angles. Double angles are sine 2 theta equals 2 cos theta sine theta. Remember. Good. So from here, now that we know cos, our cos theta is what? 1 out of root of t squared plus 1. Then we also know of what? Sine theta, which is t out of root of t squared plus 1. Let's do the substitution over here. So 2 over here. Let's bring our bracket nicely. We have cos theta, which is 1 out of square root of t squared plus 1. Right? Then we have, is it times or plus or multiplication? Multiplication. So we have t, which is sine theta, out of square root of t squared plus 1. Okay, now we can peacefully press it. Now let's do the multiplication over here. We know that with the rules of multiplication, we multiply what? Numerators, then we multiply numerators. So here, let's multiply the numerators. One multiplying t. So we have t out of root of t squared plus 1. Multiplying root of t squared plus 1. It's going to give us
root of t squared plus 1 squared.
Plus 1 all squared, right? Let's put it in that way so that maybe t squared plus 1 all squared. Can you see that? So that this square will cancel this square root off. And what are we left with? We are going to have 2 multiplying t out of t squared plus 1. So here this 2 is a whole number multiplying with a fraction. So we are going to multiply the 2 by t. And therefore we are going to have 2t out of t squared plus 1. Therefore our sine 2 theta equals 2t out of t squared plus 1. And I think it has been proven. They said we should, if tan theta equals t out of 1, show that sine 2 theta equals 2t out of 1 plus t squared. Addition is what? Commutative, right? Yeah, addition is commutative. So this is the procedure. The first thing for you to do is to draw your right angle triangle. Okay? So that you fix in the values. Whenever the value is given, when a ratio tan t or tan theta equals t out of 1, we brought the 1 because it was only t which was standing there. Okay. So tan theta equals t, and we can divide it by 1. So you fix them inside your diagram and find the missing side. After finding that one, you can find the values of sine, cosine, then you fix it inside your double angle and simplify. Okay.